Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm April.
And I'm Chuck. Give us a call. We're here until 5:30 with our phones. Give us a call here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas, you can call toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show online at dothemathonline.net. And look for us on social media. We're on Facebook, Instagram, Twitter, and YouTube.
And guess what? Skype is going to be happening soon also.
Really?
So we've got something else that we're going to be starting into here very quickly. Speaking of outlying areas in San Luis Obispo County, you got an email from Kat, who is one of the employees, works with Doc Bernstein's ice cream lab over on the coast. Wanted to know how everything was going, and nice to report everything is going along. Nice to have them still as sponsors. But if you do call from San Luis Obispo County and we do your math problem, you will automatically win yourself some ice cream courtesy of our friends over at Doc Bernstein's Ice Cream Lab. We do have some students out at Cybert Elementary School. We'll be heading out there in a little bit, taking some phone calls. But first, let's take a look at today's Math in the News.
I heard you at the game. I didn't see you at first.
Well, I was at the game. So. Anyway, today's Math in the News. Halloween is right around the corner.
Yes.
And every year we do a little something with Halloween. And tomorrow, as it gets closer, we'll get more specific with it. But I figured today, I found an article, and I found it interesting. So I wanted to figure out, all right, how could I tie this into this week? Or would I just put it off? And I'm like, you know what? We'll talk about scary things.
Scary things.
Things that are scary. Take a look at the photo that we have here. Elevator door.
Yeah.
All right. An elegant looking one, not a plain elevator door. I wanted to find something a little more dramatic. Do you think it would be scary? Let's say you're in a high-rise building and all of a sudden the cable breaks. Free fall elevator.
Yes, that's pretty scary.
So the article had to do with that, about the number of deaths and the frequency of an elevator drop and what you should do. Now, researchers at MIT, so what would you think, you know the elevator car is falling. What would you think would be the best way to lessen injury, let's say, and avoid death at all possible?
No, there was some movie where they jumped up and grabbed the top of the elevator, you know.
I guess I'm sure they looked at
fall.
every possible scenario.
idea.
And what they said was lie flat in the center of the floor and spread yourself out for more of a total body area for the impact to spread. And so I don't know. They tested all of this, and that's what it was.
Really?
All right. So I was thinking, all right, well, I can put the numbers up here in a minute, but that's kind of scary. And then some other numbers they had associated with this. Now, this is a stairway.
Really?
Now, I mean, most stairways are, but that could cause a little bit of anxiety going up those stairs right there. I mean, because you've got only the platform area on which you stand, and that's it.
Right, you've got really nothing
You've got
beneath you or
between.
next to you. Yeah.
Right, and no railing. Now, obviously, there would probably be no problem going up and down those stairs. It would just be this perception of, oh, I don't have anything near me. All right. And the last one they spoke about was an escalator. And there's Homer with this. So anyway, I mean, I just had to find something with an escalator that somehow amusing. But anyway, so here are some of the numbers associated with. So how likely?
That's
all
the
right,
question.
so here we go.
Yes.
How likely is it to be in an elevator where free fall drops? 27 out of 18 billion. That is a 0.0000015% of that happening. You have a better opportunity of dying on the stairs than you do in an elevator. Now, as far as accidents go, there are 10,000 accidents per year on escalators. And I'm assuming most of that would be something getting caught,
Yep.
you know, some frayed pants or shoelace or something like that, possibly
just
getting caught in the escalator.
Moving too quickly.
Or not quickly enough. A lot of people just get caught off guard and they just stumble and fall when getting off the escalator. Right.
Have you seen something like that? Have you had that happen? You're kind of laughing, just like bringing back memories, maybe? I'm kidding.
No, I always remember as a little kid, I always wondered where that escalator went underneath, and I was always afraid of
Getting
that.
sucked up into
Or,
it.
or as a parent, you're getting to the bottom and you're like, come on, come on, come on, let's go.
So, and then I found this other little graphic I figured we'd put up here, since we're doing the math with this, is the total rise and the run with the stairs and how you measure them out. And then this I found interesting, the number of degrees. So you can see right here the angle that they want. And then the preferred angle for stairs is between 30 and 35 degrees. So you can see if you have a ramp, obviously a little bit less, and if you're working on a ladder, a little bit more.
Right.
So I just found that interesting when I found that article about the elevators and elevator deaths and kind of scary things right there.
I would feel a lot better now the next time I go in an elevator, knowing that it's only
Right, you're like that.
27 out
One
of
in-
18 billion. Right,
Chance
right.
of an-
Just hope it's not that day. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Right now we're going to go to the phones and a student, Coral. How are you today? Hello, Coral.
Hi.
How are you today?
Good. How are you?
I'm wonderful. What grade are you in?
I'm in 6th grade.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Negative 3v
V
minus 2v equals 30.
Okay, V is the variable.
Yes.
Okay, and the directions are just to solve for V or solve for the variable?
Yes.
Okay, so let's go ahead and solve this. We know it's going to take a few steps to do it, and the first thing we notice is what? We've got two variable terms, don't we?
Yeah.
And they're both the same variable. So can we simplify this? Can we clean this up a little bit before we try to solve for the variable by combining like terms?
Yes, we can.
So what's minus 3v? Let me see if I can get that back. What's minus 3v minus 2v? So
Negative 1v.
well, let's see. Let's think about this. We can also think of this as negative 3v. Remember, subtraction means plus a negative 2v. So one way you could do it, even if you don't write this down, you can think of this as negative 3v plus a negative 2v. So what happens when you add two negatives together?
You get a positive.
Yeah, when you multiply, you get a positive.
Oh.
But think about when you add together, like on the number line, you remember? We start here, if I was going to go negative 3 and plus a negative 2, I start here at 0 and I go back 3, there's my negative 3, and then I keep going negative, don't I?
Yes.
I go minus 3 and then I go minus 2, and where do I end up here?
Minus 1.
Well, I'm going to go back 3, 1, 2, 3, and then I'm going to go back 2 more, still in the negative direction. So I'm going to end up at negative 5.
Oh.
So you got to remember, when you're adding two negatives together, they reinforce each other, and you add them together. Two negatives, when you add them together, make it more negative. Okay?
Okay.
So I know that. Let me get rid of this. if I'm going to add negative 3v plus negative 2v, that's going to give me negative 5v. All right? And
Right.
the rule we just got to remember is that when you add two negatives, they become more negative. You add the numbers and make it negative. Also, you can think about like going down, digging a hole, or going downstairs. You go down 3 and then you go down 2 more, right? That's the same as
Right.
going down 5. And so we get negative 5v equals 30, right? So there's the first step, and it's a really important step. It's just combining terms, right? Because
Right.
now, how do we solve for v? How do we get rid of that negative 5?
You do the opposite.
Yeah, so this says multiply, right? So what's the opposite of multiply?
Divide.
So that means we're going to divide both sides of our equation by the number we're trying to get rid of, which is that negative 5, isn't it?
Yes.
And it's important that you remember we divide both sides by the exact same number to keep our equation balanced, right?
Right.
So now what's negative 5 divided by negative 5?
Negative 1.
Well, let's see. We know that
Positive 1.
any number divided by itself is 1, isn't it?
Yes.
So this is, now, here's your rule. Negative divided by negative is positive, isn't it?
Yes.
So you got to remember, it doesn't work for addition, but it does work for division and multiplication. So
Yes.
those divide out, we get v. Now, negative 5 divided by negative 5 is positive 1, but 1v is just v, isn't it?
Yes.
We don't really need that. We don't really need that negative, right? I mean that 1, right? So we'll just write that as v. Now, what's 30 divided by negative 5?
Negative 6.
6, right? Because negative 5 times negative 6 gives us a positive 30. So I know that 30 divided by 5 is 6, and positive divided by negative is negative. And it looks like our answer is negative 6. And then it might be the last thing they want you to do is plug it back in and check your answer. So that would be the last thing you do, okay?
And quickly,
Okay.
let's go ahead and do that because it sounded like she had a little difficulty with
Yeah.
the negatives.
So we have a
Like
lot of negatives in here.
Adding
So let's-
negatives and now multiplying
Let's
negatives.
go ahead and do that, and we'll check it over here, okay? And so to check it, I'm going to put negative 6 in for v. So I'm going to get negative 3 times negative 6. Now I put that negative 6 in parentheses because I want to separate the negative from the 3, right? I don't want it to look like subtraction. So there's
Yeah.
negative 3 times negative 6 minus 2 times negative 6. So we got all kinds of negatives in here, don't we?
Yeah.
So let's go ahead and simplify this. What's negative 3 times negative 6?
Positive 18.
Positive 18. Now, there's a couple of ways I could do this. I could think of this as negative 2 times negative 6, or I could think of it as 2 times negative 6. I'm going to subtract, right? So this
Right.
is subtraction. What's 2 times negative 6?
Positive 12.
Well, if it's a positive 2, if I just think of this minus, just put it down here, now I'll think of this as a positive 2 times negative 6, okay? That's going to be negative 12, isn't it?
Yes.
And when I subtract a negative 12, I know that's going to become positive 12, isn't it?
Yes.
So we know that either negative times negative is positive or subtracting a negative is positive. And so we get 18 plus 12. And very nicely, 18 plus 12 is 30, which is what we wanted, so we know our answer checks.
Yes.
Okay? So it's really important to go through and take care of all of those negatives and minus signs.
Nicely
Okay?
done. Coral, you still online with us?
Yes, I am.
All right, well, I wanted you to go ahead and check that problem because as sixth graders, when you guys get to junior high, you're going to be doing a lot of those,
Yeah.
and the more comfortable you are checking them, the easier everything is going to be. Also wanted to let you know that because that was such a wonderful problem, we're going to send you home with a free meal courtesy of our friends at Johnny Rockets, so congratulations on
Okay.
that. If you do have some more problems like that, we do have phone tutors available until 5:30. 636-4357 is that phone number. Toll free, 1-866-636-6284. Right now, we're going to go and check out the brand new way that you can get a hold of Do the Math. We've got Mary Lou, and she's at Seibert Elementary. And you know what? Mac called me and said you guys were going to be getting all ready for Halloween. She wanted to know if we were doing the Halloween stuff today. We'll do it tomorrow also, but it looks like Tinkerbell is on site over at Seibert.
Hi, Hi, Mike. We are live here today at Amy B. Seibert Elementary School, ACE's After School Program, and I'm here with Alicia. Hi, Alicia.
Hello.
How you doing today?
I'm great.
I'm not scaring you, am I?
Nope.
Nah, okay, good.
I wouldn't be scared of a fairy.
Okay. And what grade are you in?
I'm in 5th grade, but my teacher teaches me 6th grade math.
Oh, okay. So kind of like a GATE program then.
Yeah.
Yes. And how do you like math?
Um,
Yes. One of your favorite subjects?
yeah.
Yeah.
That's my second one. My first one is math.
Oh, you're obviously very good at that. That's your favorite subject. Yes? All right. Okay, well, we have a problem that we need to solve, don't we?
Yes.
Okay, so let's look at the board here. It says Caden bought 9 packs of paper for $27. How much will she pay for 11 packs? Well, we need to figure this out, don't we?
Yeah.
And we have the most important information underlined, 9, 27, and 11. The first thing we need to do is, if we have 9 packs of paper for $27, what should we do? Should we turn that into a fraction or something?
Yeah.
Okay, so go ahead and grab a pen. Any color you want. Let's write that as a fraction first of all. Oh, here, try. Yeah, we got to write it like this. There we go. 9 over. Oh, watch your finger. That's okay. I know, they're smart boards for a reason. 9 over 27. There we go. Now, 9 over 27, in order to help us figure out the 11 packs, what do we need to do to this 9 over 27?
Multiply it up.
Well, can we simplify down?
Yeah.
Yeah, we could simplify down because this is 9 packs for $27. Do we want to find out how much 1 pack is?
Yes.
Yeah, so let's go ahead. What number can we divide by both of those? So it equals 1. What can we divide by both?
9.
There we go. Let's divide, obviously 9 divided by 9 is 1. So let's divide 27 by 9. What is that?
3.
3. So this really tells us that we can buy 1 pack for
$3.
$3. And that's called what? Do you know what that's called?
Simplifying.
It's simplifying, but it's also called a unit rate. Have you heard of that term before, unit rate?
Mhm.
What does that mean, unit rate?
It means the amount per box.
Exactly, amount per pack, right?
Yeah.
So for 1 pack, it's going to be $3.
$3.
So we know how much 1 pack is. So if we had 9 packs and we times 9 by 3, 9 times 3 is what?
27.
Yeah, so we have 11 packs. So what should we times 11 by? To
3?
find? Yeah, it's by 3. Let's go ahead and write that out. Oh, watch your finger right there. There you go. And what's 11 times 3?
33.
33. There you go. So we can write this as a fraction. We know that if we have 11 packs, better watch those fairy wings, they're going to get you. If we have 11 packs, then how much is it?
$33.
It's $33. And if we simplified this down, what do you think that's going to simplify back down to?
1/3.
1/3. They're equal proportions because we have the same unit rate. Okay, now I'm going to throw one at you. What if we have 20 packs? Do you think you know how much it's going to cost if we have 20 packs? What are we going to times that 20 by?
3.
Go for it. Oh, watch your arm again there. There you go. And 20 times 3 is?
60.
So can you write that as a fraction for me? So if we have 20 packs, it's going to cost
$60.
$60. And there you go. And that is unit rates. And they're a lot of fun, aren't they? It's just a simplified fraction.
Yeah.
That's all it is. All right? All right, Mike, back to you.
Thank you for that, Tinkerbell. Nice to see that our latest technology, Skype, is up and working. We'll check in with Seibert Elementary in just a little while. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, if you have seen a problem and you want to see it again, you can always go to our Facebook page or YouTube and just look for the specific day. You can view the entire program and just go right to that part that you need to. And that way you can freshen up on whatever type of problem it was that you were working on, and maybe you saw somebody and like, hey, that's the exact problem I'm working on, and I only caught the last half of it. You can always go back and look at it again. All right, April, we have a problem for you to work on here.
Okay.
We actually have 2, so we're going to do the first part of this. The sum of two numbers is 12. Their difference is 10.
Same two numbers, correct?
Right, so the difference is 10.
Okay.
And we need to know what those two numbers are.
So since I don't know either number, I'm going to call one number x. And the other number will be y.
Let's try this.
Aw. No. Oh, there we go.
go.
And the other number will be y because it has a different value. So if I'm going to find the sum, I have to add the two numbers, x plus y. And when I add them, their total is 12. And when I find the difference of those two numbers, I'm just going to subtract x minus y, and their difference is 10. So that's going to equal to 10. And this is the system. It's got two equations with two variables. And I am going to use the elimination method. So I'm going to add straight down. X plus x is 2x, and y minus y will cancel. And 12 plus 10 is 22. And now that I've only got one variable, I can find the value of x. I'm doing multiplication, dividing by 2. So x is going to equal, can I push that button? No.
You just want to move that up?
Yes. Seems like the arrow went away.
Yeah, you're going to be able to do it easier. Or you
Here,
can just write
right
it
here,
on the
just right
bottom.
here. Here, we can just pull this down.
There
Thank
go.
you. And so x is going to equal 11. So
All right. So we need to know the two numbers.
two numbers. So if this is my first number, I'm just going to say, what can I add to 11 to get 12? So 11 plus 1 is going to give me 12, and that's y. And I just want to check it. If I subtract 1 from 11, will that be 10? They both check out.
All right, nicely done. Now, you did that as
A
if
system.
students in junior high were working on this
Yes.
problem. Now we're going to go ahead and do it as if an elementary school child was working on this, seeing this type of problem for the first time in a fourth grade classroom.
Okay.
They wouldn't necessarily go ahead and be doing it this way with the system. They would probably do a guess and check.
Guess and check.
So why don't you go through a little bit about how that would happen with a fourth grader?
So if I need two numbers and I add those two numbers, I know that their sum is going to be 12. And then I'm going to take those same two numbers and I subtract those two numbers. Their sum, or their difference, is going to be 10. So then I would just guess, what are all the possibilities that I have to add to 12? Well, that is 1 and 11, or I could use 2 and 10, or I could use 3 and, I don't know, 9? And go down the list. And so I can take each one of them and check them. So if I were to plug in 1 and 11, 1 plus 11 is 12. Now if I subtract those, I'm going to use the bigger number first, so we're talking about fourth graders. 11 minus 1, 10. And then if this one didn't work, I could use 10 and 2. So 2 plus 10, that should be 12 because I came up with it from the sum, but then I would use 10 minus 2, and that doesn't work, and I would just go down my list.
All right, nicely done. And the reason I wanted you to bring that up is because that's the way a lot of students would first approach that problem with a guess and check. But the key is to have all of the possibilities, but then put them in order so that you keep track of all the ones that are possible, because sometimes they may just, oh, I'm doing 4 and 8 and 6 and 6 and 3 and 9, and they may
You
forget
don't
about
want-
like 7 and 5.
You don't
or
want to
something.
miss any.
Right. So putting them in order is pretty important also.
Yes.
All right. Why don't you go ahead and erase all of that because we've got another problem for you. much the same way.
I am ready.
All right, here we go. Instead of sum and difference, we're going to do product and sum. So the product of two numbers is 32.
So we're going to go product. I'm going to multiply two numbers, and their product is 32.
And the sum is 12.
Take those two numbers and add them together and get 12. So if I'm talking about product of 32 and we're going in order, we're going to say 1 times 32, find all the factors of 32, 1 times 32, and 2 times 16, and 3 is not divisible by 32, so 4 times 8, and 5 is not divisible by 32, 6, 7. And now that I've gone down the list and I've gotten to 8, since 8 is here, we don't have to repeat the factors. This is the set of factors of 32. So now I'm just going to plug in the numbers and we're going to guess and check. Let's see if we can get a different color here. So let's guess 1 and 32. So I know, because I came up with, no different color, I came up with these numbers from the product. So 1 times 32 is 32, and 1 plus 32 is not 12, so that doesn't work. So I'll check the next set. So 2 and 16, so 2 times 16 is of course 32, and 2 plus 16 is 18, not 12. So that set of numbers doesn't work.
We better hope it's 4 and 8.
So I'm going to check the next set of numbers. So that's going to be 4 times 8, and that's a factor. So 4 times 8 is in fact 32, and 4 plus 8 is 12. So they both check out, and our set of numbers is 4 and 8.
All right, nicely done. Thank you very much for that. Do remember, every time you phone in to do the math and we do one of your math problems on air, your name is automatically entered into a drawing, and that drawing every single day is for a family 4-pack to go see the Bakersfield Condors. Thanksgiving coming up.
Yes.
Big holiday for the Condors, because that weekend is always the teddy bear toss, and that is, have you been to the teddy bear toss?
I haven't. I've seen it, but
We've been to this for a number of years, and this is quite the event when you're over at Rabobank for that teddy bear toss. So who knows? And you could be over there for that. You could be there for any one of the games that they have coming up. I think they are well into the season now. Guys are getting kind of acclimated to the new level of hockey that they have here in Bakersfield.
Yeah, it's nice.
And we'll go back and check in with Seibert right after this. Today we're in San Luis Obispo. We're at Laguna Middle School, home of the Lancers, and today we're here to... All right, today we're at Laguna Middle School in San Luis Obispo, and I've got Isabella, a 7th grader, ready to work with us. Are you ready?
Yeah.
Okay. I love New York. You love New York? All right, we're going to do a good problem together, all right?
Okay.
All right, let's turn around. For some students that are out there watching right now, they may be like, well, what's the deal with her New York shirt on there? How would you say that? How do you think a Californian person would say that?
Coffee.
Coffee. And how would a New Yorker say that?
Coffee.
Coffee, there you go. All right, so I just wanted to make sure we're on the same playing level here, all right?
Okay.
Okay, so we're going to subtract some fractions, right? That's what you want to do? Okay, so we'll put our 2 fraction bars here, and we'll put our subtraction symbol. So, what is the first number you'd like to work with?
13.
13. Let's put that here.
4.
4. Good, because 4 minus 13 is not going to be easy for you.
8.
8. And what's your other number?
12.
Let's see what this comes out to be. It could come out to be something weird where we have a negative number, possibly. You all right with that?
Sure.
Okay. So, what do we need to do first?
You need to find a common denominator.
Right, the least common denominator, and what would that be?
That would be
Because our denominators are 12
24.
and 8, and you just said it would be,
24.
okay, so why don't you go ahead and write down your new fraction bars with 24s. And some students might be like, well, how'd you get 24?
8 times 3 is 24, and 12 times 2 is 24.
Right, and if some students didn't know that offhand, what they could do is they just start counting by 12s, the multiples, 12, 24, 36, 8, 16, 24, until you come to the first one that is common. That would be the least. And you came up with 24 in your head. Nicely done. Now what?
Now you have to subtract those two.
But do we do that first? Because we turned this from a 12 into a 24.
Oh, so you multiply this one times 3
We went from 12 to 24, and what did we do?
times 2.
Times 2. So we're going to multiply this by,
2.
and what do we get?
You get 8.
Okay, so we'll put an 8 over 24. So that will be that fraction equivalent. And what do we do here?
You multiply that one times 3.
Okay, and what do we get?
39.
39. So this is nice, because if I had reversed it, we could just go 39 minus 8. Okay? But the way we've got it set up, what is the problem now?
8 24ths minus 39 24ths.
Right. So, what do you do? Because you don't usually go 8 minus 39 and get a nice number, right? Is the number going to be positive or negative?
Negative.
It's going to be negative. Okay? So if we had 8 and we took away 39, where
Then
would we
you
be
would
left at?
have negative 31.
Negative 31. Perfect. So go ahead and write that down. And it's negative 31
24th.
24ths. Okay? So even though this came out to be a negative number, it's still not that difficult. As long as you know your integers, you can go 8 minus 39 is a negative 31. And negative 31 24ths is a valid number, isn't it?
Yeah.
All right. You going back to Brooklyn soon?
Maybe this summer.
Maybe this summer. Well, maybe when I'm in Queens, I'll see you, all right? Nice job, Isabella.
Thank you.
And once again, a big thanks to the students and staff out at Laguna Middle School. As a matter of fact, we're going to throw this out there right now. If anybody phones in from Laguna Middle School between now and 5 o'clock, as long as we get you on the air, and even if we don't get to finish your problem, forget the scoop at Doc's. We're going to tell Doc to hook you up with a whole pint of ice cream. All right? Yeah. So, yeah, hooray in the background, too. I know O'Brien likes that. Anyway, a big pint going to the first person that calls in from Laguna Middle School. If you call in from San Luis Obispo County, anywhere else, you are also going to Doc Bernstein's ice cream, absolutely free. All right, right now, we have another problem. We're going to kind of take the same approach as we did on the last couple of problems. Reason being that this is a 4th grade problem that this came from. All right. The area of a rectangular street sign is 40 square inches.
40 square inches. Got it. Okay.
The perimeter is 28 inches.
Perimeter is 28.
We need to know the dimensions.
All right, so we've got this rectangle. I don't know what shape it is other than rectangle. I don't know if it's long and skinny or almost square, but we know that the area is 40 square inches and perimeter is 28. So we want to do, I'm going to do it as a guess and check. All right? So let's look at, just like April did, we'll look at the area because that's going to be multiplication. I know that the area of a rectangle is length times width. So if the area of this is 40 square inches, there's only so many numbers that are going to multiply to be 40, all right? So I could do something like this, and I could do length and width and figure out what the area is, and then find out what the perimeter is, all right? So let's try some of the numbers that we're going to have. So let's write them down over here. If it's 1 times 40, if it's 40, it's going to be 1 times 40, or 2 times 20, right? The length and the width. Or it could be, well, 3 doesn't go into 40, but 4 does. So it could be 4 times, let's see, 4 times 10 is 40. 5 goes into 40, that's going to be 5 times 8. Let's see, 6 doesn't go into 40, 7 doesn't go into 40, and 8 goes into 40, but then I'm back to my 8. So it looks like I have 4 choices to put up here. So I'm going to figure out the length and the width. I know the area has got to be 40. I'm going to figure out if I can get 28 for the perimeter. All right? So let's try 1 and 40. 1 times 40 is 40. Now, let's see, how do we figure out perimeter? Perimeter is adding up all of the sides, right? So I know perimeter is length plus width plus length plus width, or a lot of times the formula is 2 times the length plus 2 times the width. So let's figure out what the perimeter is. I'm going to take the length 2 times. I'm going to take the width 2 times and add them together. And I want this thing to equal 28. So let's put a big question mark there. Does that equal 28? Let's see. 2 times 1, that's 2. 2 times 40, that's 80. So that's 82. So that's not even close. Got the right digits, just in the wrong order, right? All right, so let's try 2 and 20. 2 and 20, if that's the length and the width, I know 2 times 20 is 40. This is always going to be 40, right? So let's try the perimeter now. I'm going to go 2 times the length, which is 2, plus 2 times the width, which is 20. So that's 2 times 2, that's 4. 2 times 2, that's 40. So I get 44. Getting closer, but still not 28. Okay, so let's see, I've tried 1 and 40, I've tried 2 and 20. Let's try 4 and 10. So 4 times 10 is still 40. But now I get 2 times the length, which is whichever, 2 times 4, length or width, plus 2 times 10, let's see, 2 times 4 is 8, 2 times 10 is 20, that's 28. So that looks like what we wanted it to be 28. So it looks like our perimeter, let's see, we wanted to find the length and the width, right?
Right.
So we got the length and the width to be 4 for the length and 10 for the width, or 10 for the length and 4 for the width. And there are the dimensions, right? Dimensions are 4 by 10.
All right,
Okay.
Nicely done. Thank you very much for that. 636-4357 is the phone number. We do have phone tutors available until 5:30. And what we're going to do is we're going to head back out to Cybert Elementary right now. Mary Lou is out there in her best Halloween outfit. And who have you got with you right now, Mary Lou?
Again, we're here live at Amy B. Cybert Elementary at the ACES After School Program. And I'm here today with Haley. Hi, Haley.
Hi.
How you doing?
Good.
Now, Haley was just asking me if I dress like this every time for do math. And no, I don't. Actually, this is a special week at my school. And I know last week a lot of schools did the same. And it's called Red Ribbon Week. And I know, Haley, I talked to you about the Red Ribbon Week.
Mhm.
And your school was last week, correct?
Yes.
Okay. And what is Red Ribbon Week? What do they do?
They basically tell you not to do drugs and drink alcohol.
And
become alcoholic.
do you guys have activities every day that you do at all?
Yes.
Do you have any dress-up days?
We have mismatch day.
Oh, okay. Well, this is kind of like that mismatch day. Today for ours, it was Disney Day, where your dreams come true when you don't use drugs and alcohol. So that's why I'm dressed as Tinkerbell, for the Disney character. But we have more important things to do, don't we?
Yes.
What grade are you in, Haley? Did I even ask you that?
I'm in 5th grade.
Okay. So you ready to do a math problem?
Yes.
Okay, let's do it. All right, so we were doing a problem with Alicia. And our problem was Kaden bought 9 packs of paper for $27. How much will she pay for 11 packs? And we found the unit rate. We found that out of 9 over 27, we found the unit rate of 1 out of 3, meaning each pack, 1 pack is $3, right? Okay, now we have a bar graph, okay? We need to make a model of all of these. So what we want to do is start where? Where do you think we need to start for our bar model?
We need to start in the beginning of 1 and over 3.
Okay, grab a pen and do that for us. There you go. And grab a red for us. Let's choose another color. Okay, so the first one we know 1 pack is $3. What if we go to 2? Let's put 2 next. So 2 packs is going to be how much?
2 packs. Well, 2 times 3 is 6, so it would be $6.
There you go. And you keep telling us what we're going to do next. What's the next one?
We're going to have 3.
Okay, so go ahead. So 3 packs, how much is it going to cost us?
3 times 3 is 9, so it would be $9.
Okay. And I'm going to let you just keep going.
So, oops.
Yep, that's okay.
4.
And then 5 packs. How much is 5 packs?
5 packs is 15.
Okay. And 6 packs?
6 packs is 18.
And 7 packs?
7 packs is 21.
Okay. And let's go to our 8 packs.
8 packs is 24.
And 9 packs are next.
9 packs is 27.
And that's where we had started with, huh?
Mm-hmm.
Okay. Let's go to 10 packs.
10 is 30.
And lastly, 11 packs.
11 packs is 33.
Okay, so when Alicia and I did this, we simplified that down to 1/3. And then what we did is we thought, okay, how do we get to 1 goes into 11 how many times? And we multiplied out. So we just kind of, we did equivalent fractions. Now here, Haley, we're actually making a bar model, aren't we? And we can still answer this question, can't we, with a bar model?
Yes.
We know that. How much does 11 packs cost?
11 packs cost $33.
And we know it because it's right there, huh?
Mm-hmm.
And we see there's a pattern, right? Here, our numbers are increasing by 1, but down here, our numbers are doing what?
They're increasing by 3.
They're increasing by 3. So either way, we could get to our answer, huh? And just another way to help us solve something, right?
Yeah.
Good job, kiddo. Good job. All right, Mike, back to you at the studio.
Hey, Lou, I have a question for you. Did you make those wings yourself?
No, I'm not that crafty.
All right, so you purchased those. Is this an annual Halloween costume, or is this a new one for you?
Oh no, this is a new one. When they said Disney Day, I ran down to the costume store. I knew exactly what I wanted to be.
So this was Disney Day at your school?
Yes, at my school.
What were some of the other Disney characters you saw around? Some of the other teachers? Or...
Oh, we had a lot of Star Wars because Disney owns Star Wars now. So we had a lot of Star Wars characters. We also had, oh gosh, we had everything. All kind of crazy Disney characters throughout the day.
All right, sounds like fun. I think you guys had a day out at Stone Creek also,
Stone
right?
Creek, we had pajama day.
Pajama day. Interesting that was too, I'm sure, right?
Oh, yeah.
Okay. 636-4357 is the phone number. Let's go to another junior high. We have a student calling in from Tevis Junior High. How are you today? Hello?
Hello?
Yes, are you in 7th or 8th grade?
I'm in 8th grade.
8th grade. All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay, I am working on how you could find the hypotenuse of a right triangle. and they gave me the information that A equals 8, and B equals nothing, and C equals 10.
So A is 8.
A equals 8. B equals, like, we have to find out what B equals.
And C?
And C equals 10.
Okay. So if I draw a right triangle, and I mark the 90-degree angle, where should I place A? Should I place A on the right, the bottom, or, I'm sorry, the left, the bottom, or the right?
The A is usually on the left.
The left, because it's a leg? Okay. And so B, I don't know it, but I could put B on the triangle. So where should I put B on the triangle?
The B is like the bottom part.
The bottom part? Okay. And so the C is,
10.
what is
which
this called, do you know?
Hypotenuse.
So this is the hypotenuse. So we already have the hypotenuse. We're not looking for the hypotenuse, correct?
Yes, we're
Okay.
looking for the B.
So we're looking for the B, and the B is, do you know what part of this triangle is called?
The leg.
Yes, so we're looking for a leg. Is there any other information you have in order to get an answer to B? Is there some type of formula or anything that we can use?
I think it's C to subtract A2
So C
equals B2.
to the second power minus B to the second power equals A to the second power. Is there another way that this can be written where I only have addition, possibly? Mr. Pythagorean, is there another way that he wrote it?
I really didn't understand what you're talking about.
Okay, so this is a right triangle, and there is a theorem or a formula I can use called the Pythagorean Theorem. And the Pythagorean Theorem says I can take side A and square it, add that to side B squared, and that's going to equal side C squared.
Okay, so
Have you seen that in class?
Hmm?
Have you seen that in class?
I actually have not.
Okay. So I'm going to see if I can change the ink.
But yeah, I seen the A2 plus B2 equals C2, but I don't understand how could C2 minus B2 equals A2.
Okay, so it depends on what side we're looking for. So if we're looking for C, I'm gonna add A and B. And if we're looking for side B, I should probably, if I want to find this one, side B, I have to take A and move it over here. So if I'm looking for side B, B squared is going to be C squared minus A squared. And if I'm looking for side A, I'm going to start at this formula. If I need side A, I have to take B and subtract it from C.
Yes.
So these are our options. I have A squared, and I can use this combination of numbers. I have B squared, I can use this combination of numbers, or I have C squared and use this. But what you could possibly do is just always start here, fill in the numbers, and go from there. Okay? So let's fill in the numbers. A8, is that A, B, or C? That's A, correct? So I'm going to take 8 and square it. I'm going to add that to B, my unknown, squared, and that's going to equal C squared. So are you okay with that? Okay, so 8 squared, 8 to the second power is what?
64.
And to that, I'm going to add B squared. And then C squared is?
100.
100. So I want B squared. So what I can do is I can undo addition here, and I can cancel out 64. So how can I do that?
So you just get 164, right?
Okay, so what's the opposite of 64? What's the opposite of positive 64?
Negative 64?
So if I have addition, I can undo, or if I have a positive, I can undo a positive with a negative. I can subtract 64, keep my equation balanced, and subtract 64 on both sides of the equation. And b squared is going to equal 100 minus 64. So subtract 64 from 100.
It's 36.
So b squared is going to be 36. But I'm looking for what value?
So don't you have to find the square root?
Yes, I'm looking for b. So I have to find the square root. So if I take the square root of b squared, I get b. And what's the square root of 36?
The square root of 36 is 6.
So b is going to equal 6.
Thank
so we're
you.
looking
That
for
makes
a
so
leg.
much sense now.
You're welcome.
Well, nicely done. And if you do have some more problems like that, we do have phone tutors available until 5:30. Cushy's always right now got herself entered into that Bakersfield Condors Family 4-pack also for that phone call. We're going to head back out to Cybert in just a few moments, but we do have another expression that we need to solve.
Okay.
So let's go ahead and simplify. We won't solve it. We'll simplify the expression. So this seems like it's the last one on a series that some students have been working on.
Okay.
So we have negative 5x, open parentheses, 4x plus 7, close parentheses, plus 6, open parentheses, negative 1, plus 6x, close parentheses, and simplify.
Okay, did I get that right? You got everything? So negative 5x, I'm going to multiply times 4x plus 7, plus 6, I'm going to multiply negative 1 plus 6x. So we know that open parentheses means to multiply, so I'm going to use the distributive property to get rid of the parentheses. We've been working on quite a few of these, like Mike said. So I'm going to remove the parentheses here, I'll remove the parentheses here, and then we can combine terms. So we got to be careful when we do the multiplication with the negatives and the variables. So I'm going to get negative 5 times 4, that's going to be negative 20, and x times x is x to the second power, x squared. Now I'm going to take negative 5x times 7, so I get negative 5 times 7, that's a negative 35, and x times 1 is just x. Now I'll do the same thing here. I get a 6 times negative 1, that's plus a negative 6 or minus 6. And 6 times 6x is 6 times 6, that's 36. And 1 times x is x. So my first step, just to remove the parentheses, I get my 4 terms, and now I've got to look for like terms. Like terms are terms that have the same variable, but to the same power also. So this is to the second power, but these are both to the first power. We don't put a 1 there, but these are both to the first power. So this is a term all by itself. There are no other like terms like that. So I'm going to put my negative 20 x squared by itself. Now I've got an x term here and another x term over here. And I have minus 35x plus 36x. So that's negative 35 plus 36. That's positive 1 times x. So that's going to be a plus 1x. And let's see, my negative 6 is all by itself also. No other like terms, so I get a minus 6. And we don't need this negative 1 right here, that positive 1. 1x is just the same as x. So I've got 3 terms, different kinds of terms, not like terms, and that should be our final simplified answer.
All right, nicely done. Thank you for that. Well, all afternoon we've been visiting with some of the students out at Cybert Elementary School with Mary Lou dressed up as Tinkerbell, one of the Disney characters today. We'll head back out there and see what she's got going on now.
Thanks, Mike. Again, we're here live at Cybert Elementary ACES After School program, and it's been an absolute wonderful time here. And again, I want to thank Haley and Alicia for helping us out today. Thank you, ladies.
Yeah.
Did you guys have fun?
Yes.
Yes. Okay, well, I have a little present for each of you. Here's for you, and here's for you.
Thank
On
you.
top of that, you guys each get meals from McDonald's for helping
I
us.
get a large fry.
Yeah. And now hold up your shirts real quick. Okay, you guys have to promise me something. Can you do that? That you will wear these shirts at school and be the ambassadors and remind all of your friends and everybody else on campus when they need help, they need to call.
Do the math.
Do the math. And again, thank you so much. And we have another special guest with us today, Becky Stambler.
With me.
Hi, nice to meet you.
Nice to meet
Principal here at Cybert.
Yes, ma'am.
And you have a lot of activities going on campus. You want to share them with us?
Fantastic. We have a lot of things here at Cyber. We have Keep for our 6th graders. This year we are starting a math field day program, which is sponsored by the county. So we're really excited for that. And we have a blossoming Battle of the Books program going. So that's also something that the county participates in. So read and do math, both.
Yeah, you got a lot going on.
Yes,
and the
we're
math
busy.
field day is outstanding. Now, this is your first year that your school will be going, or have they?
Yes, the first year for Cyber to participate in math field day. So we're really excited to get a big 6th grade team and then have our 5th graders come along as well and be like our support system. So get them enthusiastic about the program for next year.
Yeah, and then it also goes on, if they're a part of it, they'll go on to 7th and 8th grade too. Hopefully they'll participate at their schools when they get there.
Absolutely.
It's a lot of fun. And again, it's been a wonderful afternoon. We made a lot of new friends, as you could see from back here. Right? Everybody say hi. And they all also got a free little gift for participating and letting us come on campus today. And remember, what do we always do, guys?
Do the math.
Again, Mike, back to you in the studio. It's been a great day here. See you later.
For that, Mary Lou. We do have phone tutors available until 5:30. Nice to see that there's another school being trained kind of on how to do math field day.
Yeah.
Because it's a great event. A lot of, I mean, mostly middle and junior high schools come out throughout Kern County, and occasionally there's some elementary schools. And it's really cool because those 6th graders will compete against other 6th graders. So it's not like they have to go up against 7th and 8th graders and feel like, oh, we're not going to be able to do anything like that. But anyway, congratulations to Cyber, and we'll look forward to seeing those guys in the spring at Math Field Day. Right now, let's find out who our lucky winner is. Going to see the Condors with a family 4-pack is
Alicia.
Alicia. Very nice. I believe that was our first student from Cybert Elementary. So congratulations on that. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.